Hello, my name is Julia, and this is Space Daily News channel. Later this year, the US company Rosotics will start selling a new type of 3D printer for printing large parts of aerospace industry. Traditional 3D printers use powerful lasers to heat metal wires or raw materials. Rosotics printer, dubbed Mantis, heat raw materials using a magnetic field in the 3D printer's nozzle. The company plans to begin selling Mantis printers in the third quarter of 2023 to customers who make a $95,000 deposit. And while Mantis can be configured to perform a variety of tasks, the starting point is a single print head to produce aluminum or steel structures ranging in size from 1.5 to 8 meters in diameter and up to 9 meters in height. Rosotics claims that its printers could prove useful for launch vehicles manufacturers. By the way, Rosotics unveiled the first prototype on March 24th, that is, one day after Relativity Space held the first launch of the Terran 1 rocket, created using 3D printing technology. The Terran 1 rocket consists of elements printed on a Stargate 3D printer, which, like the rocket, is also a Relativity Space development. Recently, the Stargate printer received an upgrade and now features horizontal printing for the production of longer components, with a diameter of up to 3 meters. Several new generation Stargate printers are already up and running at Relativity Space's new headquarters, and more than a dozen printers should begin producing Terran R rocket components in the coming months. Each next generation Stargate printer is expected to produce 4 Terran R rockets per year. 3D printing technology has the potential to revolutionize the space industry because it will enable the creation of engines and rockets in a short time and at a low cost. This means that the number of manufacturers of components for aerospace industry could increase dramatically. For example, the British aerospace company Aerospace creates rockets using 3D printing technology on a printer from German manufacturer EOS. Its Orbix Prime launch vehicle is equipped with one of the world's largest 3D printed rocket engines. And US rocket engine manufacturer Ursa Major is already taking orders for its Aeroway engine, which is also 3D printed using commercially available printers. With traditional manufacturing methods for aerospace, you often hear about manufacturing times of 9 to 12 months to build and test a pumped oxygen combustion engine, for example, and the enormous cost of just developing and building the first prototype. Additive manufacturing will reduce manufacturing time to a few weeks and significantly reduce manufacturing costs. 3D printing technologies are not only used by small aerospace startup companies. For example, aerospace giant Aerojet Rocketdyne redesigned its Bantam family of rocket engines in 2017, taking full advantage of additive manufacturing, reducing overall design and production time from more than a year to a couple of months, while reducing cost by about 65% compared to traditional manufacturing methods. And Rocket Lab in 2017 launched its Rutherford lightweight 3D printed rocket engine for the first time. Its combustion chamber, nozzles, pumps, and main fuel valves are 3D printed and have already launched 27 launches. And SpaceX is using 3D printing to build the Super Draco engines for its Crew Dragon spacecraft. So the use of 3D printing in aerospace is not the future, but the present. Space Daily News. Like, share, and subscribe.